So now we're going to talk about coterminal, reference, and special angles. So I've actually already written all of this, all right, but this is how I find it. I mean, the degrees hopefully is not that hard for you. This is 0, 180, this is 90, half of 90 is 45, and you're going to go on from there. Now, in terms of radians, which we write in terms of pi, this is 0, 2 pi. Remember that 2 pi is 360, so half of 360 is 180, which is this. So this is pi is 180. Half between here would be pi over 2. And then after that, we're just going up in fourths. All right, so notice that between here and here, right? Just think about it like this. Like between 0 and 1/2, I have a fourth. So I'm just going to go up by fourths. So pi over 4, pi over 2. If you add a fourth to a half, you get 3/4 pi over 4. Pi. If you have 1 plus a quarter, you get 5 pi over 4, 3 pi over 2. And then on this one, I always think about it this way, right? 2 pi would be the same thing as 8 pi over 4. And if I subtract that pi over 4, then I would get to 7 pi over 4. Okay, anyway. So this one's a little bit more difficult just because it's split up in more sections, but it's the same idea. This stuff remains the same. 0 and 2 pi, this is pi, and I'm actually going up by 30s the whole time. Now for the radians, this is pi over 6, this is pi over 3, so I'm going up in thirds. In sixths. Alright, so essentially you can add a 6 to each one of these to know what these are, but what I do is I go from this one to that one. If I add another third, I get to here. If I add another third, I would have 4 pi over 3. If I add another third, I get to 5 pi over 3, and then I basically start filling out all the pi over 6 stuff, right? I just look at it two ways. You can subtract pi over 6 from pi. So I'm saying all of that to say this. Do whatever you got to do to remember those. I'm not really sure how much we're going to test you to know this, but you should definitely, at the very worst, you need to draw yourself a circle, and you should be able to at least label all of these like I have done. Okay. Now this one says, which quadrant does the terminal side of a given angle lie? So 5 pi over 3, for example, if I'm just looking at this, I'm like, 5 pi over 3, where is that at, right? So 5 pi over 3, I know that's really close, for example, to 6 pi over 3, which is 2, so I know this is quadrant 4. And I guess if you want to look at these as quadrants, you can if you don't even know what I'm talking about. This would be your quadrants. This is like quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So that's essentially what we're talking about here. Okay, so this is quadrant 4. Now 5 pi over 6. That's a little bit less than pi, so this is quadrant 2. And obviously you can look up here, but I'm trying to do this sort of in my head so you can kind of see how I think about it. Pi over 3, that's quadrant 1. Negative pi over 6. Now negative pi over 6 would be actually going clockwise this way. Alright, so negative, remember the negative angle is going clockwise. So this one, negative pi over 6 is actually in the same quadrant as 11 pi over 6. So this would be quadrant 4. And finally we got negative 2 pi over 3. Negative 2 pi over 3 would be, let's see, that's a third, it would be right here. Okay, so it would be quadrant 3. Remember, I'm going clockwise because those angles were negative. Alright, so now we're going to talk about coterminal angles. So coterminal angles are two angles in standard precision that share the same terminal side. So what that really means is that when I'm doing something like this, for example 30, right, that's the same angle as this, but 360, if I go from here all the way around to this, that's 390. Or if I add 360, so it has the same, they share the same terminal side. Or if I subtract 360, if I go the opposite direction, if I go instead of that way, instead of going around this way, if I go basically around like this would be that would be negative 330, which is the same, okay? Now, on the next few examples, we're going to give you a couple of examples per problem. Now, if it's 500, for example, I want to give one in a clockwise direction and one in a counterclockwise direction for them to be coterminal. So, I am going to, it's actually pretty simple. You can add 360, which is 860. And then you can also have 500 and subtract 360, which in this case will give me 140, right? Oops, 140, not 144. Okay, so that's what that gives me, right? So again, it's the same idea as what I said up here. One angle would just go basically around all the way once or sometimes twice until they have the same basically the same arrow. It would look like the same vector, essentially. Alright, on this one right here, same idea. I'm going to add 360. So that would give me 300. So negative 60 and an angle that has a 300-degree angle on it, then that would look basically the same. Alright, so negative 60 minus 360, that's negative 420. Alright, what else? Okay, so if we're talking in terms of, and the same idea on that one, I'm not going to do that one though. The same idea on a problem like this, but instead of adding 360, remember I'm going to add 360 but in radians, which is 2 pi. So I'm going to add 2 pi to this. And 2 pi would be 8 over 4, so which will make this 9 pi over 4. So again, remember what I did is I multiplied top and bottom by 4. So I get 8 pi plus pi is 9 pi. Alright, so now I have pi over 4 minus 2 pi. So same idea. I'm going to multiply top and bottom by 4. So I have negative 8 pi plus pi. That's negative 7 pi over 4. Okay. So that's essentially how you do it. You just keep finding the common denominator and then you just keep adding them. Let's see, I'll do one more. I probably won't do number 5, but I'll do this one. To give two angles that are coterminal, all you do is add 2 pi and then subtract 2 pi. So in this one I'm going to multiply top and bottom by 3, this one same thing, and then let's see, that's going to give me positive 6 pi minus 2 pi, this is 4 pi over 3, and this other one I would have, let's see, negative 6 pi minus 2 would be negative 8 pi over 3. Alright, so that's how that would work, okay? And again, that kind of got scrunched up, that's a 4 pi. Alright, let's go ahead and move on to the back here. So I'm going to go ahead and go to the next page here so I don't make a mess of things. Okay, so the reference angle. Alright, so when we talk about a reference angle, we're talking about an angle that is the smallest positive acute angle determined by the x-axis and the terminal side. Alright, so I'm going to give you an example of that. So for example, if I have 150, okay, so remember, I'm going to actually draw a picture here. So 150, remember this is 90, this is 180, right? So 150 would be around here. So you have some angle, and they call this angle theta, right? So the reference angle is this one. We're going to call this reference angle, and in this case we're going to use the same letter that I do, I think that's alpha. So we're going to draw a little alpha there, and all you have to know is if this is 150, right? Or this is 150. Well, what does this angle have to be? If this whole thing is 180, then that angle right there has to be 30. Okay, so that's the idea behind it. And so the reference angle is the closest to the x-axis, essentially. So let's do the 315 one, right? So 315, I would have, let's see, this is 270, And 315 would be somewhere around here, probably. Okay, this would be my angle. That's 315. And now, the reference angle is the closest to the x-axis, right? So this angle right here, remember this whole thing, one complete revolution is 360. So this right here would be 45. Okay, so that's how you do that one. Now let's do one that has radians. And by the way, if you don't know how I'm getting this, remember, all I'm doing here in this case, since I know it's really close to this, right, to 360, all I'm doing is 360 minus 315, and I'm getting 45, and that's how I know that angle. But you just have to see where is it closer to 180. In this case, right, because I'm so close to the x-axis, I would have 180 minus 30. Excuse me, 180 minus 150, which will give me 30. All right, let's do 4 pi over 3. Now 4 pi over 3, just think about it in this is 4 over 3, is that more than 1, less than 1? It's definitely more than 1, right? And so that's going to give me all the way over here, somewhere over there. So this is theta 4 pi over 3. And now I understand this might be tougher for you, right? But look, since I'm in that quadrant, I am really close to the x-axis right here. Okay, so on this one, I'm actually just going to call this, the reference angle would be pi over 3. Okay? It's just the distance between here and here. If this is 4 pi over 3, well, all I had to do was have 4 pi over 3, and I had to subtract pi, and I got pi over 3. Remember, pi would be 4 pi over 4, so let's go get that. Okay, same on this one. Let's see, pi over 6. Remember, it has to be the smallest positive acute angle, meaning less than 90. Okay? So therefore, in this one, pi over 6 is just right here. All right, so theta is right there, which is pi over 6. But because I'm already less than really 90 degrees, then this is going to be my reference angle for that one also. So this right here, alpha is also going to be pi over 6. So there really is no difference in that one. Alright. Determine how to find the reference angle in each quadrant. Alright, so if you're looking at it, essentially all you're doing is trying to find out, okay, I'm looking for the closest distance to the x-axis. In this case, that's this one. Okay? So if it's this one, remember, well, this one is easy. Theta is equal to alpha. That's not a big deal. Alright, on this one, if theta is this, then alpha is just this little angle right here. Okay? Again, I'm just looking for the closest distance to the x-axis. So you can see that pretty easily. Probably before I even draw it, you should know that this right here, right, is the closest distance, right, to the reference angle. Similarly on this one, if we go all the way around to here, if this is theta, well, closest distance to the x-axis would be this one. Just like that. Not a big deal. If you were trying to look to see exactly what you would have, mathematically speaking, this one, they're the same. You know this. On this one right here, remember this is 180, right? So this is 180 minus theta. Or if you're trying to write it, so this is alpha. All of this angles, or you would have pi minus theta. All right. On this one, remember that's 180, and you went over that, right? So you're below that. So this actually would be 180 plus theta. Wait a minute. I did something wrong. What did I do wrong on this? Oh yeah, my bad. That would be theta minus 180. Yeah. Yes. Yeah. Okay. And then, or you can have this as theta minus pi. So both in radians and degrees you can do it like that. Then finally on this one, it'll probably be easier to subtract from 360. So this is 360 minus theta, or if you're doing this in radians, you would have 2 pi minus theta. Okay, the homework on this one is not too bad, but ask us questions if you got it, because it can get confusing, but this is actually very simple.